Alright folks, now we're going to consider the we do problem. So hopefully this practice went well for you. Alright, we're going to look at our graph and we're going to say, well, where is the first derivative of 0? And my slope is 0 right there, right? And then we consider decreasing and increasing. So at x equals 3, I had a slope, an instantaneous rate of change of 0. And then if I'm on the left, as I go to the right, I'm decreasing, which means my first derivative is negative. And then as I go to the right, on the right-hand side, I'm increasing, which means my first derivative is positive. So decreasing my interval would be negative infinity to 3. Increasing my interval would be 3 to infinity. This graph, we've got 2 points where our derivative equals 0. So once again, if we make our number line considering the first derivative, I've got now x equals 2 and x equals negative 2 as points where my first derivative is equal to 0. So if we're on the left of negative 2, we're going up, so we're increasing. Our first derivative is positive. If we're in the middle, we're going down, we're decreasing. So my first derivative is negative. And if we're on the right, we're going up, we're increasing. So my first derivative is positive. Oh, I'm sorry, that was supposed to be an I do problem. Alright, well, congratulations, you now have one fewer problems to do on your own. So now we're going to look at the first derivative test. We've got a couple functions here. So first job is to find the first derivative. And that's going to be negative 21x squared plus 21x plus 21. Set it equal to 0. Negative 21 equals negative 21x squared. X squared equals 1. Do the square root of both sides. When you do that, you need to include a plus or minus. So we've got x equals positive or negative 1 for our critical points. We make a number line with our derivative. And we've got two critical points, so two potential maxes or mins for this function. So now we've got to test 3 values. So to the left of negative 1, I'll do negative 2. In between negative 1 and 1, I'll do 0. And on the other side, I'll do 2. So for this guy, we're going to get a negative. It's going to be negative 63, I do believe. Yeah. And then for this guy, we're going to get positive. For the last guy, we're going to get a negative. So we've got our first derivative is negative, our first derivative is 0, first derivative is positive, first derivative's 0, right? At those critical points, it's going to be 0. Then we've got negative again. So we're decreasing, increasing, decreasing. The intervals for that would be negative infinity to negative 1. Decreasing, right? Then we've got increasing negative 1 to 1. And then we've got decreasing 1 to infinity. So we're still considering those critical points x equals negative 1 and x equals 1. At -1, we go from decreasing to increasing, right? So this is going to be a relative min. And at 1, we go from increasing to decreasing, so that's going to be a relative max. And we've got one more function to consider, so let's go ahead and do that. All right, so the derivative of 24, we have 2x plus 6, set it equal to 0. We got x equals -3. We make our number line. At -3, our derivative is 0. We need to test values on either side. So to the left of -3, I'll do -4. To the right of -3, I'll test 0. So we've got 2 times 0 plus 6. 6, which is positive, and then if we do -4, we get -2. So on this side, our derivative is less than 0. On this side, our derivative is greater than 0. So we're decreasing and increasing. If we were to write that in interval notation, I'd have for my decreasing -infinity to 0, -3, and -3 to infinity. Right, so now we're going to look at that point, x equals -3, and say, is it a max or a min? Well, we go from decreasing going down to increasing going up, so that's going to be a relative min.